My name's Andrew Dent. I've been working in the sustainability and innovation world of materials for the last 25 years. I run a materials consultancy and library in New York City. We have locations all over the world. And my job, my team's job has been to help our clients find sustainable materials and innovative materials for all sorts of different products, spaces, transport, that sort of thing. I want to go through 5 different areas. I want to kind of introduce you to the world of materials and sort of provide some context. We've heard an awful lot about materials over the last day. I want to kind of give you some big numbers and some understanding. I'll then talk about 4 different areas that I think are very important. Over my 25 years, I've sort of understood that there are certain things that there's what you'd like to do and what you can do. And I want to kind of promote what's possible right now. We've heard an awful lot about what we could do, and I'm excited about those. I also want to give you an understanding of what we can do right now. So, our material world, this will be only one of a few graphs. We currently produce about 100 billion tons of stuff every year as humans. It's a lot of material, okay? That's an awful lot of things. It's minerals, it's the food we eat, it's the wood that we chop down, it's also oil. Of that oil, you can see in the central section, you've got a whole bunch of stuff which is coal. We use a bit of petroleum for powering our cars. And then you've got this small amount which is basically plastics. So only about 0.04% of the 1.4% of the world's materials are actually plastic. So although it has an outsized influence, it's only actually a small amount. So just understand in terms of the volume of stuff we're producing, it's not so significant. However, this is another graph I think is also important, which is, okay, of the 400 million tons of plastics we produce every year, unfortunately, only about 10 to 15% currently are recycled, and of the bioplastics is about 1%. And what happened during the pandemic was we made 30% more plastic. So any advances we've made through recycled and through bio, unfortunately, was drowned in that tsunami of new, fresh stuff. So understand that we're actually fighting against a real challenge at the moment, trying to reduce the amount of plastics we're using, but unfortunately, we as consumers, Americans certainly, have been buying more and more stuff. We're purchasing double the amount of stuff we did in 2002. We spent twice as much money, 2 times the amount of stuff we did since 2002. So understand it's a volume problem as well as a material problem. Of the plastics we're producing, you'll notice that we produce, they are come in all shapes and sizes. But I want to point out this part, which is that the majority still are single-use packaging. So, you know, if we are trying to go plastic-free, my real driver is that, yes, okay, if you want to try and go plastic-free in consumer products, give it a go, but it's going to be challenging. You know, the majority of surfaces we touch are plastic right now, the chairs you're sitting on, the stuff we have. The concern I would have is more, can we get rid of those packaging materials? Because that's the largest volume we have, and that's the one that's growing significantly. Okay, so one nice way of doing it is simplifying chemistry. We've heard an awful lot about toxicity of materials and toxicity of chemistry. It is possible, and we saw that through the Colgate example, it's possible to reduce the number of plastics we use to a smaller amount, ones that we class as cleaner plastics, avoiding things such as the styrenics, avoiding PVC, avoiding some of those really toxic materials. You can actually reduce an awful lot of the packaging plastics we have down to perhaps 5 to 10. If we can do that, that then allows us to have simplification of recycling. We've got examples in consumer products, which is, let's say, Adidas has been doing products which are 100% one material. In this case, it's polyurethane. We've also seen it in mattresses as well. Mattresses, which we know are a terrible blight because they're made out of this non-recyclable polyurethane. This one's actually manufactured out of polyester. Polyester, of course, is a much more easily recyclable material. It's a lot cleaner than the polyurethane used for mattresses. So enabling to do that, you can then recycle all the polyester into one bin and then put the springs in the other. You've got then a product which is basically potentially fully circular and fully recyclable. So it's possible to do it in larger products. We've also seen it in packaging as well. It's not an easy thing to do, but it is possible to then change the cap so that the cap is the same material as the base, and if you can do that, you can throw it all in one place, and then it has the potential to be recycled more effectively. So we've seen this in a number of different areas, and we're seeing it through just innovations within the plastics world. And of course, yes, we would like to use an awful lot less plastics, but currently, it's the only thing we have that's viable, that's actually protecting our products, so it's what we have to use right now. A good example was in the Colgate, and it was interesting to see, it took quite a long time to do. So unfortunately, it's not an easy thing to simplify, but it's something that we should be doing because then it allows us, again, with the recycling stream to simplify it. I'm very much with Cyrill in that I don't want to have to recycle, but we do, but we have to because we have so much stuff going out there into the world. There is no real other option because, as we saw, 1% of bioplastics, and although we're seeing great advances in paper-based products, it's not have the same viability right now. So we have to accept that we need to try and do more recycling, and simplification is a way of doing that. Advanced or chemical recycling is another way of doing it. Now, most of our recycling currently is you chop it up, you melt it, and then you make it again. Challenges are that you get all the toxicity, as we talked about, and also the color. So most recycled plastics, unless they were clear to start with, end up becoming a dirty gray, dirty brown sort of color, not really sort of a nice thing to use. However, chemical or advanced recycling is able to pull out the toxic chemicals, able to pull out the color, so you end up with virtually a virgin material. Now, of course, this is a process which is not quite as well developed, a little more complicated, but it does allow us much greater control of the material and also to potentially create complete circularity, because mechanical recycling allows you to do it about 5 times. Chemical recycling allows you to do it infinitely, because you do not lose the performance of the material during the recycling process. We've seen fabrics being produced in this way. We've seen actually this process also being combined with biomaterials as well, so hybrid plastics, where they're using a bit of chemical recycled, a bit of bioplastic to create a solution. As you can see here, great transparency, good performance, because you're not losing any of that performance through mechanical recycling. Products out in the market right now are using this. Small, through recognized brands, but we'll at least be showing a proof of concept. It is possible to do it. And of course, the challenge is it is slightly more expensive because the process itself is still in its infancy. But ideally, if we do want pure circularity and we accept that we are going to have plastics for a number of years, this is the way to go. We've also talked about enzymatic recycling. That has been around for a little while. This, of course, uses enzymes rather than chemicals, a much cleaner and purer process. We've got two examples here. Carbios, which has been doing it for a while. Samsara Eco, which more recently developed it. So at least that's kind of the next generation as well. So rather than just using a chemical soup, now using a biological soup in order to recycle the plastic. When it comes to biosources, I can't stress this enough. Industrialized. You cannot be using a bioplastic if it comes from something you cannot produce in large volumes, because then you're going to disrupt some other system. So algae, so seaweed's a great one. Mushroom, of course. Things such as cellulose, so paper. Paper's a great idea, because of course we know that there's plenty of it out there. It's possible to use high volumes of this material without disrupting other industries. And cellulose also can be developed into things such as nanocellulose and other high-performance applications. So it's not just pulped paper, it's now high-performance composites, resins, adhesives, that sort of thing, all coming from that cellulose base. We can use lignin as well, because remember, from the tree, the majority of it's cellulose, but they've also got lignin as well. So there's lignin, which is used now as an additive, as a plastic, and of course we've got a bunch of it as well. So you don't have to worry about volumes, and also the cost is low. A good example of one of the challenges you have is PHA. PHA was a wonderful idea about a bio-based plastic. It's the one they manufacture from bacteria. The problem is that bacteria needs to eat sugar, and the current price of sugar is not fluctuating that much. So the problem with that plastic was that because sugar was this price, and you needed the plastic to be this price, it was never going to be viable. You have to basically, so if your raw material sources are more expensive than the plastic you want to produce, find something else. Now, we're lucky with PHA, we've now started using waste cooking oil, but certainly if you're just using pure sugar, you'll never get it down to the price of a viable alternative to a polypropylene or polyethylene. We've seen mushroom, and I've got this, Oakenworks has done a great solution of actually making it a lot more structural, a lot stronger. The stuff we've seen out there is relatively friable, almost like styrofoam. This stuff, harder, strong, can be used almost as structural applications. So mushrooms and those types of materials, which of course can be industrialized, manufactured on a large scale without using arable land, have the potential now to be used in a wider range of applications. And hemp. Why not use the boom in hemp production as a way of then taking the hemp stalks, the hemp hurd, which currently is not being used for anything else, use that. And if you can use that, basically you have other applications. So again, attach yourself onto existing manufacturing processes that use industrialized materials. You cannot be using a bioplastic that does not come from an industrialized source because it will not be viable in the long term. Cost, volume, availability is just not viable. So if you're using bio-based source, always go for the ones you know you can produce in high volume. The last one is material versus CO2. Okay, so We would love to both have a reduction in plastics as well as a reduction in carbon footprint. At the moment, most of the solutions we are offering as alternatives to plastics are going to be higher in carbon footprint. It's just a fact of life. So my advice is, although we would like to do both in unison, and we should try and do both in unison, the innovations that you're looking for in new materials, if they're alternatives to plastic, kind of put the carbon footprint to the side for the minute. Make sure you're solving for every other need, whether it's performance, whether it's price, whether it's durability, all those things. Solve those first, because if you don't solve for those first, you're not going to have a viable product. And the carbon footprint, because remember, packaging's overall carbon footprint is about 1 to 2% of our overall carbon footprint of the world. It's not a huge amount. So I'm okay with, although it's hard to say this, I'm okay with actually having a higher carbon footprint for those innovations, as long as we can get them into the market, reduce the amount of plastic, solve the problem, and then try and bring that carbon footprint down. If you're going to try and go head to head with plastic in terms of carbon footprint, it's going to be a very challenging process. And we've heard this again and again in these talks. You are not going to be able to do it alone. You have to collaborate. And it doesn't need to be with your direct competitor, even though Colgate showed that they could. What we've been seeing is that, okay, so if we're looking at, let's say you're trying to find alternatives using waste. If we're trying to, if you've got a company that's producing waste and you want to use that waste in a packaging solution, chances are that one company is only producing a certain amount of that material as waste. Let's say it's 1,000 tons. That's not going to be enough for your packaging application. Find other industries which are producing and then creating waste of the same type of material. Find non-competitive companies which can then create a critical mass of that material. So it doesn't need to be a competitor, but find other industries which have similar needs. So in trying to find material solutions, it's best not to try and start from scratch. It's best to find someone else's idea and improve on it. It's much simpler. Okay? So if you can, so that cross-pollination, that idea of adapting from other industries, try and do that. Try and take from other industries and use the other industries which are similar to yours. Because of course, there's no point in taking a material from an industry which is like aerospace, where it's way too expensive, or automotive, where it's way too durable. If you're looking for packing solutions, you need something which is a lot, doesn't last as long, is a lot less expensive, etc. So find industries which have similar needs, similar use cases, and work with those as well. Because I think without collaboration, we're simply not going to move forward. We can't do this alone. We've seen through Parley, through a lot of these other examples, how collaborate with people. Use it as a marketing exercise, but also understand if you try to go it alone, chances are you're not going to do so well. You've got to work with other brands, other manufacturers who can also get in the same boat, commit to this, work together, and then solve basically as a collaborative space. And one final thing. Okay, so having worked for the last 25 years in this space, it's challenging because I worked on innovation, and there aren't so many innovations out there that really succeeded. Okay, so what I want you to do is, sometimes it isn't the most esoteric, the most wild and out there and great looking and great marketing innovation. Sometimes it's the simple solutions. I would go with what's simple first. What's available for you currently right now? Don't try and create the most marketing wonderful solution. Find the one that works, and often that's hopefully is the simplest and the most ready to hand. Thank you so much.
Hi, everybody. My name is Melissa LaCasse. I'm from Tanbark Molded Fiber. I'm going to start by talking about why we founded Tanbark. I think giving you the context around that will be helpful in terms of the invitation I'm going to give you at the end. So Tanbark was created to produce packaging out of molded fiber. I, too, am a fan of Krista Tippett, who came up earlier. I was in distribution and syndication and business development at New York Public Radio for over a decade, and that was one of my shows. Krista's actually a mentor of mine. And I was listening to an interview she was doing one day with Robert McFarlane, the naturalist and writer, and they were talking about this concept of what kind of ancestor do you want to be? What are you doing now that will make a difference for people generations from now who you won't even know? Couple that with another point for context. Our family company, the company of my husband's family, has been making the machines and equipment that produce molded fiber packaging for over 3 decades. My husband has been turning the wrenches on those machines since he was 13. He is an expert on how to make the machines that take bio-based materials, plant fibers, and form them into forms. We had started to receive calls from people out of the blue saying, I don't have access to this material. I want to make my packaging out of this material. Can I buy a machine? I can't get the producers of type 3 molded fiber to call me back. And so with that interview from Krista Tippett and this knowledge and this data set about this underserved market, we created Tanbark. So I'm focusing today on type 3 molded fiber. There's 3 types of molded fiber. Well, actually now there's dry molded fiber as well. Type 1 is like a garden pot. It's called slush molding. It's what you get at the nursery. Type 2 is ubiquitous. It's an egg carton or a 4-cup carrier. Type 3 is a really great and promising material for replacing rigid plastic, single-use plastic. It's already widely available, but only in commodities. So if you need 50 million parts more, it's the same cup, the same bowl, the same plate, the same takeout container. Mass production on a massive scale, limited room for flexibility and creativity. Tanbark is different. By the way, these aren't our products. These are coming out of Europe, which is way far ahead of us. But Tanbark is different. We have first-to-market machines that are innovative for a lot of reasons. One, it's a very open platform for all the designers in the room. We have opened up the possibilities in terms of shape, structure, color, embossing, and how much depth you can get from the package. But really they're innovative because they're smaller, which means that we can produce volume orders that are thousands of pieces, millions of pieces, and because we design the equipment in-house, we can scale to millions, 20 million or more. So the choice to switch to molded fiber is a simple one. Again, it is one of the most promising solutions for some of the single-use plastic out there. We're starting with pretty easy adopters, Corp B companies, B Corp companies, such as Luke's Lobster. They're a Maine-based company, but maybe some of you have visited their restaurant here. Regulation and the fact that they're a B Corp drove Luke's to our doorstep. Luke's is opening a restaurant in Seattle, which, because of their compostability standards, which are very rigid, they wanted to get rid of their PLA line paperboard, and so we were able to develop a piece. These are prototypes here. Our pieces will look much nicer, but we were able to develop pieces that still function the way they need them to, but are compostable. Let me talk a little about our supply chain. So we're based in Maine, and Maine has a legacy of the pulp and paper industry. So we're really growing out of that legacy. And we get our trees from the northern woods. And the northern woods in Maine and across the north of the United States and into Canada are managed for sawmill trees. So the tree grows, you cut it down, it goes into the lumber in your house, it captures the carbon. Tanbark is providing a market for the loggers who go in and cut the low value trees, they call them, around the sawmill trees, so the sawmill trees can grow faster. So we're supporting a market that also supports a carbon sequester forest. Okay, let me bust some myths. Molded fiber is brown and boring. Wrong. There are lots and lots of possibilities, and we are opening it up for you because we can do lower volumes, we can play with color, we can play with shape, and we can play with embossing. Come play with us. Another myth, volume requirements are a barrier to entry. No longer true. We have just had a splash page up until this week, and the names that are household brands that have found us are pretty impressive. And part of it is just the fact that we can produce volumes. One of them was 10 million parts, but they need it to be 5.5 inches tall. Our machine can do that. One of them's 20 million parts, but they need to service Spain, and Spain no longer wants. By the way, I'm going to talk to Lime Loop after this, because Spain won't allow people to ship in plastic packaging anymore. So we're going to work with this household named brand to allow them to service Australia, Spain, some of these places that are working on, well, they're way ahead of North America, let's just say that. Okay, so volume requirements. We actually noticed, though, with the calls we were getting, that we weren't small enough. There are brands that want us to do, there are medical devices that want us to produce parts in the thousands. So we're going to make a micro machine for them. So there's lots of possibilities now with Type 3. Let me talk about funding. So I want partners to play with us. And we need partners to come in and be willing to put a little bit of time and a little bit of money on the table. But we're incredibly fundable through the USDA, the NSF, lots of government resources, because we have a platform that can allow us to innovate with this material. So if some of you have that low-hanging fruit, if it's made out of thermoform plastic, come to us. We could probably replace it in a couple months if it's secondary packaging. But if you want to also work on innovating, like the shampoo bottle, or let's try to figure out what we can do with the types of companies that are doing what Notpla is doing with seaweed, with nanocellulose. Maine has the aquaculture industry, the nanocellulose wood-based industry, and we have Type 3. So there's a lot of resources just in Maine alone for starting to play in this space. Again, it's not just okay to say you're sustainable. We really need to see leadership in the C-suite that cares about sustainability. If you're frustrated with your company, if your company is not doing that, come talk to us. We specialize on trying to find one project that solves a lot of different goals. So maybe there's a goal your company has that we can help you solve. And again, people have talked about this today. Collaboration, collaboration, collaboration. Let's collaborate. I want to work with jewelry companies, people that are makeup companies. I want to work with medical device companies. I go into all these stores and I see things made out of plastic that I know we can create. And so I need to just have partners in the private sector space so we can work on the low-hanging fruit. And then we can go get funding for the harder to solve problems. So please find me after this if you would like to talk about some pilot projects. Thanks, everybody.
Thank you. Thanks, both of you, and welcome back to the stage here. I have to say this material myth busting is one of my favorite topics. I've been working in the world of material development for over 20 years, and especially when it comes to next generation materials and alternative materials, it's wildly confusing. So I'm gonna ask you pointed questions, okay, panel? Okay, so first question, I'm gonna go to you, Andrew, because you kind of run the library here. So how do you start to inspect these capabilities and limitations in order to make sure that you're advising people on the right material to be using?
Well, I mean, yes, that's based upon what the manufacturer needs. So you often have to ask the right questions, because often what they're trying to, it's not like I want a replacement for material A, it's I'm trying to make this product more desirable for my customers. I'm trying to make it more so it lasts longer, so it pours better, so it doesn't break down in transit. So often it's getting them to ask or answer the right questions before you even get to the performance aspect.
What if everyone who comes to you says, my material is the best?
Well, I mean, that's clearly not true. I think it's, we do assess, and the whole idea is that, once you've spent enough time in the material world, you understand there isn't an awful lot that's new under the sun. There really isn't. Once in a while, I'll get sort of amazed by something that's completely new, but it's rare. So you can kind of get an idea if someone's coming to you with a great innovation. You kind of know where it sits within the material world. The natural materials are the ones that still amaze, because with plastics you kind of know what to expect. With metals, with glass, with ceramics, it's a known world. With biological materials, you've got no idea. Mentioned about self-healing. Biology is able to create solutions that we wouldn't be able to do in any real way. So I think I'm still amazed and excited by the biological solutions, because they often bring something which is just unexpected. And we've seen the real innovations within materials has been within the biological field in the last 10 years.
Yeah, I totally agree. And I saw you nodding. Please jump in.
Yeah, I think the best, for us, we do need to believe in the material science of the innovation, and this is a strategic approach, right? I mean, some people want to be plastic free, and I like that you have to have a focus on things. You can't solve all problems at once, but you should not give up in solving them. And so you have to kind of more or less first set your targets, and then you need to test. I like to just work with innovators. That's why we're investing into material innovators. I like to work with them early stage, because often they have something which is valuable, but they want to go somewhere totally else. Not sometimes it's a coating that they're actually inventing, but they want to be a fiber, or they got the money for a specific application, they can't hit it, but on that path to that, they invented 10 other things where they don't see value in it. So our role at Parley is to work with the innovators early on, identify where we see value, and then right away bring it to the manufacturing of like the best brands in the world. And also connect it with, I would say, more like a pan scan on what other problems could we solve with creating a feedstock for that material. And otherwise, you have probably amazing new material, and you mentioned that before, but the feedstock actually is totally counterproductive. And you have monoculture somewhere, or whatever you do, and you cut forests or whatever. So I think you need a 360 view on things. On the other side, you need to get it very, very quickly in the hands of people who can actually make things with it.
Yeah, actually, I'm going to just pipe in on that one too, and just say that the missing middle here is the existing supply chain. If my toothpaste friends are still here, I don't know if you still are, but you know, it's making sure that you are developing a material that can actually fit into an existing supply chain. Because if you don't, you then have to then figure out new manufacturing and figuring out new technology. So, yeah, great point. So, Melissa, you did an excellent job explaining your business and how you've overcome some of these barriers in terms of quantity and other aspects. Tell us more about how you're working to overcome some of these challenges that you're posed by your customers.
Okay. So as I said before, there is a lot of low-hanging fruit. So one of the things we're finding is that the early adopters are often driven by regulation, and often they're either a B Corp or they have a European parent, and they know what's coming and they want to get their supply chain ready. Type 3 isn't the solution for everything. It's just the solution for a lot right now that's made out of plastic. And so it's just, I think, a really easy, an easy solution right now for a lot of products. However, there is, the tech needs to be worked on and innovated. The Type 3 process, I don't know if I said this before, but it was invented in Maine about 100 years ago. It's been around forever. It was largely set aside because people said, we have plastic and styrofoam, we don't need this. And in the last 3 years, people are starting to pay attention to it again. So I firmly believe there are innovations that are being developed in other industries that, if we just thought about it differently, can be applied to Type 3. And so you take that low-hanging fruit as a way to get an inroad into the material, but then we start working on some of the challenges. How do you put a cream in it? How do you shape it differently? There's a whole bunch of structural and performance issues that I just think in the next 5 to 10 years will be solved. And it'll be with seaweed, nanocellulose, polysaccharides, just all the materials we've talked about, a lot of them bio-based. And at Tanbark, we think we can approach this in a non-toxic manner because we think there is enough market opportunity for us to not have to cross the line into the toxic chemicals. So we're trying to be there for customers who want that.
Thank you for bringing that up. Actually, I was going to say one of the issues that I have with several of the materials that I've come across in my time is they end up covered in plastic. So you might make this wonderful new material, but it's now covered in plastic. So then you have an end-of-life problem that you didn't have before. So it's find it very complicated to try to solve one problem without creating another problem. Please.
Yeah, and I think that's exactly where we have to be very, very careful right now, because so many examples of a material that looks fantastic, cactus-based or whatever, and bio-based itself. I know Europe, I think you need 7% of biological material to be called bio-based. and then the other 93 can be whatever. So the truth is, and also biodegradable doesn't mean anything. It just means that it breaks down at some point to a certain level that we don't even have defined yet, right? So we want to know, and I think that is where I like clarity. I rather say this is a plastic than saying this is a natural material that is actually containing plastic. And I think we need to be rather pure and say, okay, we're going for natural materials, they're natural, and we're going for plastic, that is plastic, that's fine. You know, then you just stand up for it and say, this can only be done in plastic today. I'm making it in plastic, even if I hate it, and I don't want to do it, but I have to. Still better than virgin if I use recycling material. But on the other side, if it's natural, or it's biofabricated synthetic biology, then it's created by organisms without being toxic at the end, ideally. So I think it's, at this point in time, very misleading what we're seeing in the press, and I think we all agree on that. Everybody comes out with like a new innovation, like a mushroom leather, and at the end there is a poly coating on top that gives it a little bit more substance or protection, and poly means plastic, right? So yes, there is a lot of, I think at this point we can afford to be extremely honest, and everybody will appreciate that.
Do you look like you want to pipe in?
Yeah, just thinking about the pulp paper and the Type 3, it's actually interesting when there's a desire to innovate, how quickly things happen. I mean, I've been watching the evolution of these type of pulp paper packaging, where the first pulp paper bottle was basically a PET or polyester bottle with some pulp paper around it. You know, it was, and so now we actually started to see, we got thinner and thinner layers, and now we're at a point where some of the suppliers actually have solutions which are entirely bio-based, which can then go back into the recycling stream, which are, you know, so we've seen that in probably 2 to 5 years, which is incredible development time. So when there is a desire to do this, then it can happen really quite quickly. That's what I'm always surprised about. And you put these scientists to task and say, develop this for us, and they can do it quickly.
I don't agree.
So
I annoyed Suzanne Lee from Biofabricate 3 years ago, 4 years ago, when I said, oh, imagine that, you see a snow leopard in the mountains, and instead of killing it, you just get the DNA and you grow the fur. And she's like, Cyrill, can you please never, ever say something like that ever in your life again? We have no idea how to grow fur. And this will take probably another 10 years until we do. I like the ambition, and to say, you know what, I want to do this now, and I'm going to burn $100 million, and I don't know where I'm going to get at, but it's to really invent new materials can be a drag. And I think that's the big difference between the digital revolution, which end of the day is some cables and code, and the code can be changed. Material innovation just takes so much time. And it took us 7 years to get Adidas to 96% of recycled plastic. An old, outdated material is now at least recycled, and it took us 7 years. 7 years. And we had all support, they're paying the price for it. Of course, they're making mistakes, it's a big organization, but we agreed 7 years ago that we're gonna do it, and they did everything they can. And they're really investing money into it. And this is just recycled plastic. We're not even talking a replacement of plastic. All the plastic investments they made, they look nice in a press release, but I doubt, I know, that they're all not ready for manufacturing, for large-scale manufacturing. You can make 100 pairs from them, but not like 100 million pairs. And I think material innovation takes time, and it costs a lot of money. And without investments coming from sovereign states, like governments, we will not do that. And that was the same with digital. Digital wouldn't be at that stage if not the governments would have thrown a lot of money at that. So I think that it's all about collaboration also on the financing level between the private sector, private investors, and the governments.
You're speaking my language right now. I will say though, I'm going to split the middle. One of our first projects, which actually turned out to be patentable, I think it's ridiculous that this was patentable because it's such a simple solution. But again, nobody's paid attention to Type 3. You really can't over-exaggerate that in these custom solutions. It was a company that has a European parent company, and they want to get their supply chains in order in the United States because they know it's coming, the plastic bans and the regulation and the extended producer responsibility. We're also based in Maine, which has got a really low population, but we're we've banned plastic, we've got EPR, we have just our ocean is warming very quickly, so we're just seeing it every day. So we're suing 3Ms. The state of Maine is suing 3M because of the toxic PFAS situation.
And fighting salmon farms.
Yep, and so much. But I guess what I also wanted to say, though, is I really wanted to stress again that I have seen firsthand and have been invited by groups in the government to, when we come up with a private sector partner and we find ways to experiment with this, it is a highly fundable situation to work on new materials. So I think it is hard, but if you have money, some money, not a ton, and time, you can get met in the middle.
And offtake. And if you have offtake, if you have clients and demand,
Yes.
then it's getting even easier to get the
Yes,
money.
exactly.
And not only equity, but also very cheap debt.
And the other thing is, if you solve one problem for one industry and it has broad applicability across others, medical, makeup, health and beauty, CPG, which a lot of these solutions we're trying to get do, it's also more fundable. So.
And I want to add something, sorry for hijacking.
Do it.
There is something here's the thing. I don't expect brands to finance or to fund all these solutions because they simply don't have the money. And even if they're big and famous and rich, the investment they can make in innovation is a joke. And they are measured by the success of these investments, which makes them very anxious. And that's why they're making mainly marketing investments that look good and they can justify them and write them off, and they're not bound to that. So what brands can do is they can give offtake agreements. That means if I'm an innovator and the brand says, if you hit my specs, I'm gonna buy material from you, and these agreements can often be quite soft. They don't even have to 100% legally commit to that. That moment, the innovator can go and get loans, or he can get equity, he can sell equity, he gets good investments, because it proves that he or she is on the right path, and there is an actual market. So what companies can really do, support innovators by proving that there is demand.
That is so right. Tanbark has received about $1 million in grants, and it's because of offtake agreements that we got from major hospitals, major brands, that said if they do what they say they're going to do, or if they get to this point, we will buy from them. They are right. There is a market.
And it doesn't have to be perfect. It can be, as you just said, and that's a very important point, if you meet these specs. Because companies often think, I commit to buy something where I don't know if I can use it. You know what? You don't even have to say, you don't have to commit to anything what you can't use. If you meet these specs, and specs can be price, and of course you should add a little premium and say in the first 5 years you're paying 20% more or something like that. For that I have novelty and I have a story to tell. But on the other side, if you meet these specs, if it performs like it should perform, then we're going to take that. I want to add something else. What you said before, that material, if it's mechanical recycled, for example, has a different tint. That's correct. That's why we actually attacked exactly that mind barrier by making a uniform for Real Madrid with recycled material that can't be white, because we are dragging it off the beaches in Maldives. And you know what? These uniforms were not white. They were a little off-white, a little dirty, and it looked actually fantastic. Even on the photos it looks great, because it doesn't break out that much, because clean white actually creates shit photos. And so the off-white had a little silverish style, and that's what a designer can do. We can actually sell things that other people think are shit. And we are the people who defined the standards in the first place. So why are we not selling material that is stained, or material that looks different, or that is a little broken, a desaturated color? It actually looks fantastic if you sell it right, if you combine it right. So I think we should forget the comparison of old materials with new materials. We should just treat these materials not as a mimicking, but as a new material. Oh, we're gonna grow a steak. Who wants to be, why are you not just making something new? Define it new, tell it new, have a Michelin star chef defining a new quality, a new material. And I think that is where we are a little blocked, and we think we are so innovative. I think it's time to let the old standards behind and have designers together with innovators define new standards, even aesthetical ones.
Thank you for that. And I think it's a little bit of a common thread, other than the fact that calling these things shit, which I don't disagree with all the time, but
I didn't have these fancy things.
Embracing the difference of some of these new innovative materials, I think, is a wonderful thing, and it shows that grace that we were talking about earlier, too. So thank you very much, panel. Round of applause.